The pressures of World War II dictated research in many areas. There was a requirement for a machine which would handle large amounts of data with high speed and accuracy. As a result, a computer named ENIAC was made. The original objective for inventing this computer was to create a fast calculating machine. The computer needs to be instructed in a special language called programming language. Several such languages have been evolved by computer experts. Each language is suited for a certain type of application. Before the days of electrical engineering, attempts had been made to provide results to mathematical problems by mechanical means. Charles Babbage gave the world its first computer called Analytical Engine. Analytical Engine could store data and perform arithmetical calculation. Hermann Hollerith devised a statistical tabulating machine, which was electromechanical. Howard Alkin built a general-purpose calculator called Mark I in 1939. In 1946, ENIAC, or Electronic Numerical Integrator and Calculator, was made for the Army. ENIAC takes the honor of being the first true electronic computer. Computers such as ENIAC, which consumed large amounts of power, are known as first-generation computers. The second-generation computers evolved in the mid-50s. They were made up of transistors, smaller, faster, cheaper, and more reliable. Third-generation computers were made with silicon chips. The packing circuits in third-generation computers came to be known as large-scale integration, LSI. Fourth-generation computers represent very large-scale integration, VLSI. The progress from one generation to another is marked by computers, which are compact, less energy-consuming, faster, and reliable. Today, computers are useful in almost every application. Some main areas of computer application are scientific research, business applications like payroll and personnel records, office automation, word processing, desktop publishing, electronic office, stock control and sales, banking, insurance, and stockbroking. Industrial applications like electricity, steel, printing and paper, engineering design, space technology, communications, air travel, transportation, road traffic control. A computer receives information, processes the information as instructed, and then presents the result in a usable form. Two kinds of information have to be input: program and data. Program is the set of instructions which the computer has to carry out. Data is the information on which these instructions are to operate. Hardware is the visible electrical and mechanical parts of the computer. Hardware is linked together to form a working unit called a computer. Programs, language, rules, and associated documentation used in operation of a data processing system is called software. There are two categories of software: application software and system software. Hardware is driven by utility programs called system software. These utility programs are input and stored permanently in the computers. Programs written by users are called application software. Computers are classified by the type of data that they are designed to process. Data may be obtained by counting or by the use of measuring instruments. Data that is obtained by counting is called as discrete data. For example, the number of people living in a city. Continuous data is the data that is obtained through measurement. For example, temperature obtained by a thermometer. A digital computer is a counting device that operates on discrete data. An analog computer deals with variables that are measured along a continuous scale. A hybrid computer is created by combining the desirable features of analog and digital computers. Digital computers are made for both special and general purposes. A special purpose digital computer is designed to perform one application. A general purpose digital computer can be used for various applications. Computers are classified based on size. Microcomputers or personal computers are small and general purpose computers. Mini computers are smaller and costlier than personal computers. Mainframes are large, costly, and have enhanced storage facility. Supercomputers are the largest, fastest, and most expensive computers in the world. Computer languages are smaller and simpler than natural languages. They have to be used with greater precision. There are three types of computer language: machine language, assembly language, and high-level language. Machine language. Here the instructions are written as a string of binary numbers, 0 and 1. It is the only language understood by the computer. Writing programs in machine language is very tedious. To overcome this, symbols and codes were developed. These symbols or codes are substituted for machine-level code. The language of symbols or codes is called assembly language. Both machine and assembly language are called low-level languages. High-level languages are English-like languages. They are easy to learn and provide better documentation. Examples of high-level language would be C, Basic, Pascal, etc. Since the invention of computers, many programming approaches have been tried. Primary motivation is to handle the increasing complexity of programs. The structured programming approach is a powerful tool in solving problems. Here, the problem is viewed as a sequence of things to be done. It consists of writing a list of instructions for the computer to follow. The instructions are organized into groups called functions. Very little attention is given to the data. As the programs grew complex, the structured approach failed to give the desired result. Object-oriented programming is an approach to problem solving that attempts to eliminate some pitfalls of conventional programming methods. This approach uses the best of structured programming features, adds new concepts, lays emphasis on data management, saves data from accidental modification, has only a limited number of functions working on the data, breaks programs into objects. The language chosen for problem solving is determined by two factors: application in hand and computer hardware. High-level languages make things easy for a programmer. High-level languages could be 3GL, that is third-generation languages, 4GL, fourth-generation languages. Third-generation languages are efficient, but with the increased demands on data processing, they are consuming more time. Fourth-generation languages are a set of tools out of which one or more are selected as and when they are required, each being designed to cope with a specific task. 4GLs are for experienced users with more emphasis on what is wanted than how it is done. We can classify programming languages as follows. Commercial, emphasis is on files of data rather than numerical computation. Example, COBOL. Scientific, used in engineering applications, for example, Fortran. General purpose, used for commercial or scientific applications, for example, Pascal. Interactive, specially developed for terminal use, example, BASIC. Systems programming, used for developing utility programs for hardware, for example, C. Correctness, a program should produce output as per specification. Reliability, a program should function accurately for a long period of time. Robustness, a program should be developed in such a way that it can handle exceptional amounts of data. Execution efficiency, a program should execute in small core memory and should process data fast. Ease of use, a program should be user-friendly. Maintainability, there should be a sensible program structure and use of standard language features so that it is easy to understand, make changes when necessary, and to enhance. Portability, a program should use standard features of an operating system so that the program can be run on different machines.